and welcome back to this week's Everything is Mathematical challenge. As you can see, I made it. And I even managed to get the curtain pole in through the front door. But did you manage to calculate the maximum length of curtain pole I could buy? To solve this problem, which is the kind of real life challenge that real life could throw up at any time, you need to use good old Pythagoras' theorem. So as you'll have realised, the heart of this problem is that tricky right-hand bend. How do we get the pole around there? Very quickly you'll realise the maximum length you can get is equal to this diagonal here, which is the diagonal of a square whose side is twice the length of the corridor. So this is 2 metres and this is 2 metres. If we call this length here L, then we can use Pythagoras to work out the length, as we know that the square on the hypotenuse is equal to the sum of the square on the other two sides. So L squared is equal to 2 squared plus 2 squared. L is equal to square root 8, and therefore approximately L is 2.82 metres. Now that's great, that's a really long curtain pole, but it's not long enough. But of course, as you know, we can take in a longer curtain pole because we're not restricted to carrying it horizontally. We can raise it such that one edge is nearer the ceiling. Doing that, we create another right-hand triangle which we can use Pythagoras on. The bottom length is L and the height is the height of the ceiling, which is 2.5 metres. If we call this length here H, then we know that H squared is equal to L squared plus 2.5 squared. If you do that calculation, you'll quickly find that H is approximately 3.77 metres. Fantastic. Not bad. I've ascertained that I can take a pole of over 3.75 metres around the right angle bend in a corridor that's only 1 metre wide. And that's exactly what I did. Mind you, although we were quite lucky with the pole, we weren't so lucky with the wardrobe. And that's been stuck in the corridor for the last 2 days. Oh well.